how I tell my friends and how I tell my family when they're like, "What does Hasura do?" Sounds like a Japanese knife manufacturer. So that's where I work. Actually, what Hasura does is it generates instant APIs on top of any database. So really saving a whole bunch of work for that kind of boring CRUD operations where you can build a bunch of microservices. Now, I called this talk Transcending Microservice Hell in Search of Supergraph Nirvana. So if you're expecting there to be a bit of a conversation around Kurt Cobain and the music of Nirvana, then unfortunately this is probably the wrong talk for you. Here to talk about microservices, though, definitely the right talk. I'm going to throw up a quick poll on Menti. So if you've all got your phones, this is the only time in the talk you're allowed to use your phones. Hit up menti.com, throw in the code, and I'd love to grab a little bit of, I'd love to grab some answers to some of the questions I've got on here, to be honest. So the first question I've got on here is this one. It's, I am using GraphQL in production. The answer is quite simple. So yes, no, or soon. Hopefully through the magic of WebSockets, it will pop up. There we go. There's no prize, by the way. This is purely for my own self-interest.
No prize for M95.
No. I mean, you can get some bragging rights to being like the one person in We're in Dev now. There's definitely more than 4 people in the room and on Zoom. There we go. We've got a few. I usually like to do these because then we can start developing some alliances in the rooms between like the front enders and the back enders, all of this kind of thing. So cool. We've got most people not using GraphQL in production, but give it a couple of months and then people using GraphQL will be up there. Next question is, have you heard of Hasura? So pretty evenly split now between yeses and nos. Obviously, now that you've heard that we're a Japanese knife manufacturer, you can all say yes. And then I think the final question is, I'm using Hasura in production. So I've got 1 yes, I've got 1 in dev now. Please come and speak to me at the end. I'd love to learn more about your product. And then we've got a few no's. So I think that's everything. Oh, and there's the final one of I am one of these. So I'm walking from the street for these. That's actually what I am. So a few different people in here. No DBAs. Sad face. Awesome. So we'll get back to the presentation itself, a little bit about who I am. I'm Adam. I'm based in Sydney. I've been based in Sydney for probably like the last 7 or 8 years. I've been in Australia for maybe 14 years. I don't like to make this all about work though, so a lot of the time, especially during weekends, I spend on roofs and chopping down trees with the SCS. It's quite fun. Now, I've been in open source for basically my entire career. I'm kind of one of those people who got really bored at uni and was like, I'm going to try this open source thing, do a computer science degree or anything. I was just like, I'm going to try this open source thing. And that's kind of, the rest is sort of history. Now, what I hope you'll take away from today, a few of these things, I want to go on a little bit of a trip through time of kind of how we got here. I also want to describe what a supergraph is, because it's a really old term, but it's started to come back into kind of prominence now. Why we should care about things like composability, and then we'll run through a little bit of a demonstration of what a supergraph does, with the idea that you'll take away a vague sense of malaise for having to build a lot of this yourself in the past. So where we've come from, this is that trip through time. The right way to do things has changed a lot over the years. Originally, the right way to do things was to create static pages for everything. I still do this sometimes. So maybe a quick show of hands, I haven't done a Menti for this, but who has ever created a static page and served it straight up through like Apache or Nginx? I have, yeah, there we go. A little bit more esoteric. Probably a lot fewer people in the room have done this, but for like 6 months, the way to go, the thing to do things was to use these things called edge side includes to get all this dynamic content. I never did this, but if you're the person who did this in the room, just feel really smug at yourself that you were kind of part of that zeitgeist for a while. Then for maybe 5 years, probably about 5 years ago, SPAs were like all the rage, and everyone wanted like a Vue or a Vue.js or a some other kind of single page application. And now what we're seeing a lot of is this move back almost to like taking single page apps, but actually hosting them on the server and doing what edge side includes did. So doing this kind of React server components. Really, what this means is that just things change over time. They change for different reasons. People decide to do things in different ways. And the way that we do architecture, the way that we develop, the way that we write, it all changes based on kind of, different reasons. Now, one of these reasons is you know, because someone else has done this, right? Like AWS said, hey, we need to do APIs for everything. Thou shalt not have a monolith. Thou shalt talk between thy services with different APIs, and there must be an API endpoint for everything. So everyone said, okay, we're going to do a whole bunch of different APIs. And if you're a really large company, you probably did it quite well. And if you're a small company, you had one guy or one girl who's managing 20 different microservices and wondering why they can't actually get anything done. Then we started being a little bit more data-led, and someone, don't know who, but someone said, you know what, we should store as much data as is humanly possible. We should, every little interaction from our customers, we should store and put in a data lake or put in some kind of massive warehouse where we will do something with it at some point in the future. And no one really knew why. So we kind of got these APIs, we've got all this data, and we don't really know what to do with it. And then finally, where we're kind of at now is this idea that a lot of companies are starting to be more data product led. So they've got all this data, they've got some APIs, and they're trying to realize the value, or they're trying to monetize the data that they've got. So we're starting to see a lot more data products, which is really lucky, because otherwise we'd all have a bunch of data, a bunch of APIs, and again, not know what we're going to do with them. So how we think about these architectures changed over the time. And this is one of my favorites. It's build the monolith because it's really easy to do, just requires me to do it. And then where we went is we went into this massive sort of spider web of all these different microservices talking to all of these different backends, because our data products, the things up here, whether it's the application or the API or the service or whatever it is, it needs all this data in order to power it, in order to power the experiences. So here became very kind of like a point of consternation, because it's often quite hard to talk to these microservices, to manage API contracts, even if we're using things like GraphQL. And then came things like streaming data, where we're starting to add in operational data stores. We're starting to shove information in from things like Kafka, doing CDC, effectively moving data around organizations and taking ownership of different parts of data, again, in order to fuel these microservices. And so the reason I asked kind of that front-end, back-end question earlier on was to sort of see where people fell on either side of this red line. And we're all friends here, so it's not going to be like an us versus them thing. It's more just kind of a comment that we do naturally fall into these camps where folks on the front end, they've got specific requirements. They want to move really quickly because they're often customer facing, right? They're the teams who have got UX practitioners who are doing customer workshops, and they're saying, what do you want as part of your application? Okay, you want this cool new feature, we'll go and talk to the devs, we'll do this kind of thing. And just for clarity, devs can exist sort of up here as well, like back-end devs can exist up here as well, creating our back-end for front-end systems, creating our APIs that talk to our back-end APIs. They want to move really quickly. The back-end teams, though, kind of the data teams as I call them, so product team and data team rather than front-end, back-end, the data teams themselves, they're probably a little bit more concerned with things like reliability, probably a little bit more concerned with things like security, because if they're the masters of these data domains and information is leaked, like it's not these teams that are at fault, these teams have just kind of executed the data APIs as they should, it's these teams, and these teams need to be a little bit more focused on creating maybe a bit of a stable environment. So you have this healthy tension between the team up here wanting to move quickly and a team down here who's like, oh, not so many changes, like we're just patching like the latest Heartbleed bug or whatever, like we need to move a little bit more slowly. And so effectively you start getting into a situation where, I don't know if anyone's seen Office Space, it's one of my favorite movies, but like your product teams come in and they're like, we can have another API really quickly, that'd be great. And the data team is like, we're so busy with other things, we haven't even thought about building your APIs. Now, this is where, and there's a really good blog on this that I think was released in like February this year. It's called the serverless monoliths. And I really like this idea because it's taking an approach of having like a backend for front end, but having a backend for database. So it's having all of your data at the bottom, have this backend for front end or a serverless monolith where you can query in a composable way across any number of different entities. And a way that I commonly see organizations start to go down this pathway, I think maybe Netflix did it like this, is they've got all their data in their data systems. They've got a bunch of microservices on top of those. And then they build another microservice in terms of like GraphQL. They build a whole bunch of GraphQL resolvers, talk to their microservices, they stitch everything together, and they say, voila, Supergraph. Now, in terms of what a Supergraph is, it's a very complicated sort of like definition, but I'll try and break it down. It's both an architecture type and an operating model. And what I mean by that is that you've broken down your different data domains with, architecturally. It's like this team is responsible for this database and these microservices. This team is responsible for this database and these microservices. But actually, we're joining things together to form sort of one API. And then in terms of an op model, it's really just that. It's really just kind of taking the work that people are doing within their own subgraphs, within their own domains, their own data domains, and joining everything together. Now, where the word actually came from, if we think back to when Nick Schrock and Lee Byron originally kind of conceptualized this term of GraphQL, they actually originally wanted to call it Supergraph. They were like, it's this graph, and everything bubbles up. And then someone said, and then they said, it'll be composed of these different GraphQL things. And then someone said, Supergraph sounds really stupid. Just use GraphQL. And so GraphQL was the thing. The specification was the thing that lived on. But actually, people have kind of dug back into the history books and said, you know what? If we compile or if we comprise many different GraphQL endpoints, this idea of a supergraph actually sounds really good. It sounds like what we need to do to join up data or to federate data from multiple different sources. So that's where we're seeing it a lot more again. Now, what should a supergraph do? We've already talked around, composability. We've talked a little bit around that. We'll dive into it in a little bit more detail. So it should be unified and semantic. There should be one layer. There should be one API endpoint, if you've watched Lord of the Rings, to rule them all, and one place where these product teams at the top should be able to consume this data from. So they shouldn't have to be able to, or they shouldn't have to be forced to manage multiple different endpoints in order to consume that data. It should be composable. So again, if we're using that single endpoint, that single API call should, through the power of graphs, be able to go and retrieve information from multiple different backend sources, again, without the product person having to know how that data is structured or having to know how that data is related kind of behind the scenes. Because that's a data team problem. They should be worrying about the models. They should be worrying about how the data is structured, not how they should actually retrieve that data. Governance should be really important as well. So folks sort of in this team here should be concerned about their data, and folks in this team concerned about their data. At the supergraph level, we should be bringing all of the rules, bubbling up all the rules that those teams have put in place on their data to make sure that we've got no centralization, to make sure that we've got no kind of team having to manage the supergraph itself. It should automatically bubble up from everything beneath it. And then finally, it should just do all of your query planning. It should do all of the execution. And part of that is, whether we're building with resolvers or other things, it should just automatically do that based on what the models provide. Now, a comment about composability and why composability I think is important is everything that I've described here. If we don't have a composable endpoint, we're really just using like API gateway or Kong or something like that, right? We're just taking a pass through and saying, okay, on this endpoint, run these different things. So composability is really important because it means that one query from the front end can actually talk to multiple different backends, whether we're talking to GraphQL endpoints, whether we're talking directly to databases or otherwise. So a quick look at how we've built our supergraph, because it's following very much the same kind of principles. The only thing that we've done, I think, that is perhaps a little bit different is we're using a connector-based approach. So a few of the other developers in the Australian GraphQL community who work for Hasura, I'm sure they've spoken about this, they're on our data connectors team. And what they're doing is they're building the integrations that go straight from the supergraph into things like Postgres or Oracle or Snowflake or Mongo. So effectively, we're not having to build multiple different GraphQL endpoints and multiple different layers. We're just composing across those databases natively. The other thing that I think is really useful to add in is, again, if you've watched Arthur, you'll know this one. Authorization, he does it for free, much like the janitor. So with authorization, it's really important to, again, understand that we've got information coming from multiple different backend sources with multiple different potentially rules that govern access to that data. So here, what you'll see in the demo is that we've got 3 different unique pieces of data from 3 different databases. We've got information here from a Postgres database, information here from a Mongo collection, and a second Postgres database here. We might also have a bunch of authorization rules that come into play. So things like role-based access control, client-based access control, attribute-based access control. And so what we can do is we can use things like the open data domain specification to define access rules in a way that is, again, open source and friendly to everyone, that allows us to describe what our API looks like. And if we can accurately describe what our API looks like, then that means that we can run APIs, or we can generate APIs in the same way that you would manage configuration on a server with something like Ansible, or set up your infrastructure like you do with something like Terraform. It becomes a lot more declarative in the way that it's defined. So what we'll show is we'll show how we can query one thing. We can use the results from that one thing to query the second thing. And then we can use the results from number 1 and number 2 to query the third thing, all in one go. Kind of magic in our demo. So hopefully folks on the Zoom can see this. So this is just a blank install of Hasura that I've got here. I'm going to take a few shortcuts. I'm going to throw some configuration up there just to make things a little bit easier. But effectively, what I'm going to do is I'm going to go and connect myself up to a couple of different databases and a Mongo. Yeah. Or yeah, okay, there we go. So we'll connect it up to a few different things. As you can see, this is kind of a smattering of the different databases here. Obviously, any derivative of these works as well. So I was testing things like Aurora the other day, or Enterprise Database. So anything that's kind of one of these or like one of these is included. Now I'm going to just throw in a few different things. I'm going to throw in an environment variable for my accounts data. So that's kind of number 1. I'm going to then connect up to a second database, much in the same way as before. And I'll throw in a separate environment variable for my loyalty data. And then let's connect up to a third one. Let's connect up my Mongo store. Can't remember what I called this one. I think I called it KYC. Through the power of autocomplete, we can connect up our third one. Now, what Hasura has now done is it's now gone into those databases and it started to introspect the data. So much in the same way that if you were building an API, you'd be like, okay, so what models do we have? How are they related? How do we create these semantic relationships? We can do all of that here. As soon as we track the information in these tables, we can track both the tables and any of the primary key foreign key relationships, effectively allowing us to traverse the graph with any of those relationships. E.g., as we see here, accounts have users, users have credit cards, accounts have transactions, and so on. We can also do this with between any of our different data sources as well. So whether we've got 2 Postgres databases and a Mongo database like we see here, we can join all of those together, effectively creating semantic relationships between multiple different database types. So that's a little cheeky thing that I did there to do all of this configuration so I'm not hunched over a keyboard for 3 minutes. And what it's going to do is it's going to create all of these foreign key relationships between our accounts table, between our accounts database, our Know Your Customer collection, and our loyalty data store as well. And by the time we go back to our API, we should now have all of this filled in. So we should be able to do really simple things like, hey, let's just query our name information in our accounts database. But we should also be able to now do things that are a lot more complicated. For example, we go to our users database, and we might want to maybe grab the username. We might want to get the number of points they've got from that separate data store, the separate Postgres data store. And we might want to grab their email address from the Mongo data store as well. And do all of that in kind of like 100 milliseconds. So we've got Bernard here, we've got Virginia here, we've got their points balance, and all of these 3 elements are coming from 3 different data sources. Now, on top of that, because we've talked about authorization, what I'm going to do is I'm going to throw in some authorization for us. I'm going to throw in, say, the user ID, throw in like a token or something like that. So maybe using like a JSON web token. Run that again, and now we only get information for one user. So it's the same query, different kinds of results. So if we head back to here, what we've seen is we've seen how we've connected up to multiple different databases. We've created a composable API where we're throwing any number of queries at it, and it's kind of sorting out behind the scenes all the relationships, getting that information from our backend, and then presenting that to the user. I'd love to take some questions now. We've also just released Hasura version 3 in alpha, so please try that out on console.hasura.io. Love to have some questions from either the room or the Zoom. Oh, they're Ryan. Oh.
Is there a recommendation or recommended approach of breaking changes or migrating in the Supergraph?
I think honestly, do it the same way that you would with like standard GraphQL resolvers, right? Like the whole benefit to GraphQL is that it should be one of the benefits is that it should be versionless. So rather than worrying about sort of breaking changes and saying, okay, like we're going to create a new major version here, we're going to roll out these changes, we're going to do this here, we're going to do this there. The way I see it done most successfully is kind of in a rolling way where we're, adding new features is really easy. Taking away features, we can say, let's use the Supergraph to create computed values. So really simple example, maybe our first name and last name endpoints or values disappear and we get replaced by a name field. We can add that name field, great, adding additional change. And then to remove it, the Supergraph will actually tell you, and our Supergraph, and it will tell you who's using those fields. So you can kind of go out, you can change your mobile app, you can change who's consuming that, and you can say, hey, we've got this new field now. And then when the usage of those elements goes down to 0, then you can just roll it, maybe cut a new major release or just kind of roll it out sneakily. But it's effectively a way where you can roll your changes forward without sort of the traditional REST approach of, oh, we need a new API.
I had a fairly general question about Hasura. What's the deployment model? Can I run my own Hasura instance on my own cloud infrastructure, or is it purely hosted?
No, it's anything. So the demo that you saw today was on Docker on my laptop. So we've got a lot of customers who, like Commonwealth Bank, for example, run Hasura in AWS in their own environment. So they don't use our cloud. They use their own cloud, and they take the Hasura containers and they run it on Kubernetes or ECS or something over there. So it's, use your own infrastructure, use Hasura infrastructure, put it kind of wherever you want.
That's great. And then, so related, we had one question from online from Mo. On the subject of Supergraph, I can see some benefits of that, but wondering if it might create a single point of failure, or am I missing something?
Yeah, totally true. And that's where this serverless monolith comes in, right? So typically everyone goes monolith bad, microservice good. Right? That's kind of the thing that everyone sort of said. I think where I'm seeing a lot of change now though is towards these serverless monoliths. So it's kind of okay if it's serverless because we can distribute it globally. It can be quote unquote planet scale, all of this kind of thing. So the Supergraph that we've built in version 3 and everything is it's serverless Hasura. So effectively, there's no single point of failure because each request that comes in is, its own geographically isolated interpreter of GraphQL and compiler of SQL. So in the old world, yes. In the new world with serverless, not anymore.
So it's basically completely stateless and can stick it anywhere.
Yeah.
I had a question about Supergraph idea because I was probably one of the very first GraphQL meetups in San Francisco, and he was talking about that Supergraph idea. It's interesting that it's come back, but is it the same thing as the sort of Apollo federated or just federated graphs?
Really similar, and I think folks in the room who are familiar with Apollo, they do a really good job of the federation of existing GraphQL endpoints. So if you've done this kind of thing, and you've built your microservice, you've built your Graph API, and then you put Apollo over the top, like that's where it would fit in. What they might typically see Apollo though is sort of up here in the BFF. So you might have Apollo up here talking to a couple of different endpoints rather than being the org-wide Supergraph. The only reason for that is because I think where we've focused a little bit more is in building these data connectors, these ones here. So I see it where Hasura kind of acts behind, below the line in the data layer, and then Apollo acts above the line because Hasura provides a GraphQL endpoint, and then developers are developing on Apollo on the front. I actually used Apollo in that demo. So Apollo for my mobile client and the Apollo client for the, I didn't show the web view, but I've got a web view as well. But really, yeah, they kind of play nicely together. I generally put Hasura in the data layer and Apollo in the product layer though.
Yeah. I mean, the idea is the same. The beauty of GraphQL is you can compose it.
Yeah.
It's been true. One of the problems though, I think we've realized over the years was scale up actually across data systems. Is there any, I'm assuming this all works great if you have Hasura-based times. and you standardize those at the data source level. What happens if you've got arbitrary endpoints with potentially arbitrary types?
So, I mean, you can start to cast your types. So I think especially in the Mongo connector, I'm gonna have a look in Mongo, because with Mongo,
I think my
please.
explaining problem to them is that there's only a limited set of out-of-the-box scalar types for that define instead. And so even things like date, time, and date are not actually defined. And there's now sort of a bit of work that Andy Merrick still does. I think he wrote a good job of projects, putting together a spec for making sure you can match scalars like that. But the same problem is if you don't have the same types, you can't really match easily across the graphs. And that is actually a problem. There is one. I don't know how far it's gotten because I haven't looked lately, but really the first two out of the box were date and daytime, which are pretty standard types that you kind of would expect to be out of the box. So look, I think there's ongoing work with that happen, but something to watch out for you.
I can't seem to find out where it is, but with Mongo, for example, obviously because it's NoSQL, we can add different columns, we can add different data types pretty easily without kind of a migration or anything. You know, if we just dump some new content in there in a new one. And so somewhere, and I wish I could show you this, but somewhere we can just add these new types. And I think what it does is it does like a conversion between whatever the type is in the data source and then what's presented on the GraphQL API itself. Awesome. Well, if there's no more questions, I'll...
A couple more coming in from online.
Okay.
Does Hasura support any DBMS connector, for example, Microsoft SQL Server or Oracle?
Both of those, yes. There's obviously a few more esoteric ones. So, you know, I'm working with a customer at the moment who we're building an Apache Phoenix connector for, and that's based on like HDFS or something. So a lot of the common ones are supported. We effectively took an approach where if it's used by a lot of people, we'll bake it into the product. If it's used by not a lot of people, then we'll see if anyone needs it before we build it. Some of the other ones we're building at the moment are things like DynamoDB because people want to store information in DynamoDB and get things out. So yeah, if there's specific ones that you're after, apart from SQL Server or Oracle, give me a shout and I'll be able to let you know what we support.
And another question here from Colin. Is the endpoint exposed by each connector GraphQL compliant? In other words, is the Hasura Supergraph basically a GraphQL federation server over the per connector GraphQL endpoints?
No. So each of the connectors acts as an HTTP server. So the only GraphQL endpoint is the one in the Supergraph. Hasura communicates to its data connectors via, will soon be, I think we're changing format or we're adding a different format, but basically over HTTP. So Hasura talks to data connectors connectors talk to the database, and then kind of the end of it is a GraphQL compliant endpoint or REST endpoints if you want to get information out of Hasura. But if you wanted sort of a GraphQL connection on top of each individual connector, then, or each individual data source, then you'd effectively implement multiple Hasuras. So let's say you had two, you know, we'll use our examples from earlier, SQL Server and Oracle. You'd put one Hasura in front of Oracle, one Hasura in front of SQL Server. And then if you wanted to stitch them together, you could use either Apollo or again, Hasura. So you can do it like I did, where we put everything in one Hasura, or you could split things up and put a Hasura on top of each domain. I've got some enterprise customers who are doing that because they want control over their own Hasuras.
All right, thanks very much. That's it from the online audience.
Nice one. Awesome. Thanks ever so much. I'll throw